Alright folks, so we are back with episode 2 of this LLM from scratch series, and in this video what I wanted to cover is the tokenization piece and also how you can do the data preparation, building the batches of data which includes the input and the target, and that we will see how to do it in this video. So first of all, we are using this tiny Shakespeare data which we will use as a raw text. So once we download using this command, then we can load this data to the in memory, and the data that is being loaded is stored in this variable which is raw text. Right now, any of this deep learning or machine learning algorithms generally don't understand the text, so we need to convert those text to some sort of numerical representation. We can send those numerical representations to the machine learning or deep learning based models, right? So there are several tokenization technique which we can do. So one of them is like character based tokenization, where we can split uh, the whole text into characters, and the individual characters will become tokens, right? So here the advantage of using character based tokenization is that you will have a smaller vocabulary. So if you compare with a word level tokenization where there are a huge number of words which are present in the English dictionary, that is not the case if we are building a character based tokenization. So one of the problem with which is associated with character based tokenization, that if you are building a character based tokenization then do the embedding, then the context length would be very high, right? So because each of the characters are token, then once you convert those tokens to embeddings, so each of those characters will occupy a huge length in the memory, so the context length will be very high, and that will not be an optimized way to train a model. But again, the advantage of using a character based tokenization is that you will not get any out of vocabulary tokens if you use a character based tokenization. So what we will start with is we will start with building a word level tokenizer, where we will split the documents or the raw text based on the punctuation, and then we will remove the null tokens, and we can have a processed variable or a list where we will have a word level the tokens which is been extracted from the raw text, right? The like first few tokens of the process list, then you can see like the number of tokens are also very high because we are doing a word level tokenization. So there are a lot of words which are present in the English vocabulary, so the vocabulary size will get increased, but it will be much more meaningful because the words are much more meaningful rather than the individual characters. So instead of using the character level tokenization, we can use the word level tokenization. So we can convert those textual representation to the token IDs using this word level tokenization. So just to visualize this process, what we generally do is we cannot send the text directly to the LLM. So what we have is, this is like input text. For an example, we have taken this sentence which is like the initial few words are like LLM from scratch, then the other words are there in that sentence or that sequence. Then what we do is we kind of create a process text. So based on the punctuation or the white spaces, we can divide this sequence to individual tokens. So you can see like LLM is one token, from is one token, scratch is one token, then so on and so forth, right? So then what we do is we kind of create a token IDs for each of these tokens. So this is kind of a numerical representation of this individual tokens, right? So 121 is kind of a representation of the word LLM, 30 is kind of a representation of from. So in that way we can like go from textual representation to a numerical representation. Then what we do is we use the embedding methodology, which I also described in the PyTorch essential video of this series. So we kind of create a multi-dimensional representation of these individual token IDs, and that we generally send to the LLM. So we will see when we build the decoder based LLM. So along with this token embeddings, we also add a positional embedding which we add to this token embedding. Then we send that to the LLM. Right? See, is we are creating a word level tokenizer, and we are naming that tokenizer as hello world tokenizer. So we kind of create the unique words using that processed variable, and we kind of do the sorting also, and then we kind of check the size of the vocabulary. Right? So we can see like there the size of the vocabulary is like close to 14,000, and then we kind of create the vocabulary. So what we generally do is we kind of do a looping on this all unique words, and then we get the index and the token, and we map the tokens to the index. Right? So you can see this is how the vocabulary looks like. For each of the tokens or the words, we have a corresponding token IDs. Right? So this is a representation of that. Then we kind of pass a word, and we can get the corresponding token ID for that particular word. So this is kind of a wrapper which we have created, a class named as hello world tokenizer. So where we have two methods which are like encode and decode. So this encode will help you to go from text to the token IDs, and the decode will help you to go back from token IDs to the text. Right? So then what we can do is we can just look at the first few characters or the first few tokens of this raw text. So these are like first 100 tokens of the raw text, and then we can like test out this hello world tokenizer. So we can see like we are passing the vocabulary to this hello world class, and we are getting back the tokenizer. So using that tokenizer we can encode the text, and we will get back the token IDs. So these are the token IDs for this text, and then we can also come back to the original text using the tokenizer dot decode. Right? So this is a way to go from textual representation to the token IDs, and again going back to the textual representation from the token IDs using the decode method. Right? So but the problem with this methodology is that we will have a lot of outer vocabulary words. Right? So the base text that we have used, that may not contain all the words of the English dictionary. Right? So we will have a lot of outer vocabulary words, which we can see here also. Like if we have given this text like LLM from scratch, then if you try to do the encode, it will throw an error. Right? So it will tell you that there is no key called LLM, because this was not part of the text that we have used to create this tokenizer. Right? So to tackle this, what we can do is we can take an in-between approach, which is like what we also call as byte pair encoding, which was also used in OpenAI's GPT-2 model, and we will kind of leverage that in this tutorial, and this will kind of help you to tackle the out of vocabulary words. So we will not get an error that a particular word is not present in the vocabulary. Right? So these are the steps which are involved in creating this byte pair encoding tokenizer. So let me explain you with an example which I have taken from this link. Have a text corpus with the following four words, which are like A, B, B, C, B, C, D, and C, D, E. Right? So then what we do is at the initial phase, we initialize the vocabulary, which consists of all the bytes or characters of the text corpus. Right? So we have this 5 unique characters or bytes, which are like A, B, C, D, E, E. So these are the 5 unique characters that are present in the vocabulary. So we initialize the vocabulary with this unique characters. Then what we do is we calculate the frequency of this characters. So you can see like we counted that A is present 1 times, B is present 3 times. So in that way we kind of calculate the frequency. Then what we do is at the step 3A, we find the most frequent pair of two characters. Right? So we will see that the BC pair, the pair which is equals to BC, has a frequency of 2. Right? So we can see like BC was present here, and also it is present here. Right? So the word or the token BC has a frequency of 2, right? So then what we will do at the step 3b is we will merge the pair, right? So the BC, we will merge BC to create a new subword unit called BC. Then what we will do is we will update the frequency counts. So update the frequency count of all the bytes or characters that contain BC, right? So we can see the BC has occurrence of 2. Then what we will do is we will add this BC to the vocabulary, right? So here we counted two set of characters, then we can like increase the frequency of 2 to 3 set of characters, and so on and so forth. So we will keep on repeating this step until and unless we reach the predefined number of the vocabulary count, right? So this is the way people generally create the byte pair encoding. So it has a mix of the character based tokenization and also the word level or a subword level tokenization, right? So here the chance of going out of vocabulary word is less because we have a mix of both the words, right? The character based tokenization and the word based tokenization. Okay, so now what we will do is we will install this tick token library, which will enable us to like do this byte pair encoding on our text. So we initialize this tick token dot get encoding of GPT-2. So as I previously mentioned, the GPT-2 uses the byte pair encoding, so we will leverage that here. Then we encode the raw text and we get this tokens variable, and we can like check the length of this token. So we can see like the length of token is 338025, right? And we can also see the first few tokens, right? Now let's talk about how we can prepare the batch where we will have the input and output pairs, right? Because if you want to train any machine learning based algorithm, we need to have an input and output pair, right? So if I again take this example, like I am learning LLM from scratch, then the subsequent words. So then at first we will convert this sentence to the token, and then we will convert the token to the token IDs. So these are the token IDs which we have. Then we can create the batch of data, right? So here we kind of decided that my number of rows are 4. So and the other dimension of this batch is a timestamp, right? So this we can call it as timestamp or context length, or any other name, right? Or we can also call it as T, right? Which denotes that this is a timestamp, right? So then this is how we can create the batch of the data. Now going from batch of the data to the input and output pair, what we generally do is, so we will build a decoder based LLM. So the task of the decoder based LLM is to generally predict the next token, right? So if we are pointing here, so if you are at this point, your task of the LLM is to predict this token, right? When you are here, your task is to predict this token, right? So in that way, what we generally do is we will have this input data. So this input data again denotes the number of rows, and the other dimension is timestamp. So if this is your input data, then this will be the target will be a shifted version of this. So we can see like for each of these tokens. So if I talk about this is 110, right? So if you give this input to the decoder based LLM, the target should be 150, right? So for 110, the target is 150, right? For 150, the target is 33, right? So in that way, we can create a shifted version of the input, and we can get this target data, right? So this is a way generally we can create the input and target pair, and that we can create as a batch, right? So for an example, like if we are having a batch where the number of rows are 4, so this can be one pair of input. Again, this can be another pair of input, and this is another pair of input, and this is the last pair of input, right? So because for this token we need the next token, so we will add an extra token to this buffer, right? So if we can call this as buffer, this is nothing but buffer, then these are my inputs, and we need one extra token to have the target for the last token, right? Which is for 33, we need the 38 token, right? So keep that in mind. Like we will, if you want to create a 4 by 6 batch size, then we will need 4 cross 6 plus 1, right? So we will need 25 tokens to create this pair of input and target batch, right? So you can see, like, if we are creating this buffer where we have taken like 24 tokens from the tokens list, and then we kind of create uh, the x variable using this dot view function, which will convert this stretched out vector to a matrix of 4 cross 6, right? So then what we, as I mentioned, like we will need one extra token to create the y variables or the target variable. So what we will do here is we will make this 24 to 25, and then we will do the dot view, and we will leave out the last token, right? So which will give me this 4 cross 6, and then while creating the y, we will start from the second token or start from 1 till the end, right? So the y is kind of a shifted version of x, so we will have this pair, and that will kind of act as a one batch of input and output pair, right? So then we can like create a class. So this code is adapted from Andre Karpathy's lecture, which is also helped me to create this whole series. So what we have done here is we have an initialize function where we accept the batch and the time dimension or the context length, and based on that we will create this get batch function, right, where we start with the current position as 0, then we create the buffer, and while initializing the buffer we pick up one extra token, which is like b cross t plus 1, right? And then we create the input and output pair, and we keep a pointer which is a current position. So whenever the current position is greater than the total length of tokens, then we again reinitialize the current position equals to 0, right? And then we return back the x and y pair from this get batch function. So this will help us to create batches of data, right? So at first we initialize this get batches with b equals to 4 and t equals to 6, and we get a data loader, and using this data loader we can call the get batch function, which will return the x and y. So you can see like this x and y is the input and output pair, and we can see like the y is kind of a shifted version of x, because we will always try to predict the next token whenever we have given a particular token. So like 22307 is kind of a output value for the token, which is like 5962, right? So in that way we can create the pair of x and y, which we can use while pre-training the LLM, which we will discuss in the fourth video in this series, right? So with this concept, I will end this video. I hope you got a concept of how the tokenizer works, what are the demerits of the character level tokenization. Then that can be tackled with the word level tokenizer, but again we have an issue of outer vocabulary token using a word piece tokenizer. So we have implemented the byte pair tokenizer, which can tackle the issue of outer vocabulary token, and we have implemented, and then we kind of used this get batch function to create the input and output pair, which we will use during the pre-training phase. So with this I will end this video, and in the next video we will implement the decoder based LLM from scratch, right? Thank you. See you in the next video.